All right. Welcome, everybody. I am Valerie Lockhart. I'm the Executive Director of Code Savvy, and we are here for another kind of deep dive into some software engineering talks that we've been producing the last couple of months. And I have Paul Yamas with Entrust Corporation here with me today. And he's going to be talking to you a little bit about security, cybersecurity, and how you can make your applications and your projects more secure. So I'm going to hand things over to Paul.
Hi, everybody. Good afternoon, as of the day of the time of this recording. My name is Paul Yamas. I currently work at a company called Entrust here in Shakopee, Minnesota. I'm also currently the board chair of Code Savvy. And under Code Savvy, obviously one of the programs that we administrate under Code Savvy is Technovation. So excited to be here. The My background is in at least my degree is in mechanical engineering, but I've worked in a lot of different industries from automotive, semiconductor, aerospace, and currently Entrust is a financial tech company. And within our business, there's two different sides. There's the work that we do to develop the hardware that's used to code and print and code credit cards, personal IDs, be it for governments, passports, etc. On the other side of our business, the physical products. On the other side of our business, there's the digital software solutions, right? So you think about all the transactions that you run in your apps or in your online. So when you log into, say, your banking app, the transaction, the means by which you establish that connection and run those transactions, that's typically our software that's running, securing that connection, ensuring that your data is secured and your transaction is secured and your personal information is secured. There's And when it comes to cybersecurity, that's something that we really are super cognizant about these days. So just taking it back a little bit to cybersecurity and where that comes from, right, or the need for it. Um, it goes back to the days of where you're even before computers, where you're trying to figure out how to uh, set up what we call ciphers or some kind of cryptography to be able to code your messages so that only the person that's intended to receive it could decode it, right? You could even think about, for example, even going back to the times of uh, Leonardo da Vinci, right, and all his ideas and his journals, what he would do to try to protect his intellectual property, or what we call IP in the corporate world, is he would write his journals using essentially like a mirror, so that he would write everything in reverse, right? Versus just writing straight out. And then the other thing that he would do is leave out key aspects of his idea, so that somebody who maybe came across his journals couldn't perfectly replicate it because some key aspects of that technology was not being documented in his journals. So that's one way that he was doing, or a couple of ways that he was doing there to protect his his information from ending up in somebody else's hands that he didn't want it to go into. And you fast forward all the way into the times of, say, World War II, when the Allied forces were trying to figure out this super highly encrypted Nazi code that was being used during the war by the Nazis or by Germany, to be able to transmit their information. And that code couldn't be deciphered. Everybody tried to do it, and ended up that it was essentially a mathematician and his team who developed essentially a computer, one of the first computers out there that could, and it was very mechanical in nature, versus today's that are very much electrical, silicon based, microchip, microprocessor. But the ability of that computer to be able to take those ciphers and decode it was a cutting edge breakthrough that really changed the world of how you essentially create cryptography, but also find ways to crack it. And here we are today, when you have businesses that um, are working to create those kinds of firewalls and cryptography or um, coding to be able to ensure that your transactions are safe, that your identity is kept safe, that people can't go into locations that they're not supposed to and be able to abstract data or extract data. So there's there's a lot of activity that goes on there, and when you think about your apps, there's certain things that you're working on relative to being able to ask people for their information, and for them to feel secure in being able to provide it in a way that's secure. And then also, what are you doing within your apps to try to protect it, right? Um, one of the When I get back to the cipher and cryptography uh, topic, there's a great book here for those of you that are interested. It's not very big. I think it's kind of intended for middle school, kind of a middle school level audience, but it's called "Can You Crack the Code?" and it's by Ella Schwartz, and it has a very um, uh, good understanding, from a beginner's level into a little bit more intermediate, as to how the history of ciphers and cryptography and why it was used. And it's it's a good foundational book to understand the importance of data, data transactions, data security. Um, and obviously, when you're looking at your apps now, some of the things were, having been a mentor for several years, one of the things I tell the teams is, when you're developing apps that are intended to collect information, obviously, be it personal in nature, for example, even logins, for example. Some of the things to think about there is, okay, well, um, you're trying to develop a minimum viable product, right? So you're not necessarily looking at, well, I want to include all this kind of, cybersecurity and ensuring that I'm applying good secure coding practices um, to address common, what you would say, probably common vulnerabilities. But it is important to understand that there is an expectation, right? So when you go and pitch to judges, for example, judges might ask you that question, like, okay, well, what you're collecting this personal information, what are you doing to secure it, right? And understanding that, well, this is a minimum viable product, and understanding that while we're collecting some of this information, what I would think about in answering that question would be, here are the things as we develop the next round, or if we were to develop the next round or the next iteration of this app, it would be to include certain aspects of uh, cybersecurity or firewalls, or things that we would test to ensure that the app is less vulnerable to a cyber attack or information being somehow extracted for malicious purposes, right? So, there's certain things to, as you get into that conversation, right, and start thinking about the topics of what those things are, that's where you kind of start to dive into the specifics, which we can get into today. Um, and talking to Val, we're talking about what some of those things could be, right? So, for example, when you think about um, uh, security flaws, right? There's certain things that we look at relative to testing software, um, be it through. So you think about, for example, when you're going online, right, and you're or going into an app, and you're entering your information, right? That information, you think about that place where you're entering that data. That's what you call essentially your GUI, or your graphic user interface, right? Um, and there is a place where that data is being sent, and that data is being sent into what we call essentially a database, right? And that's typically what you have is a front end user experience, or your UI. um, we call it UI or UX, a combination of there. But then there's the what's happening on the back end, what we call the back end, and that typically is your database, which is typically not just one specific database, but it's typically what we call a schema, right? Of databases that are all tied together, and that's all being managed with code that we call typically SQL, right? Or um, uh, uh, structured query language, right?
SQL.
SQL, right? But everybody likes to call it SQL for short. That's typically what it is. But essentially, what you have is the code that you're writing to be able to accept that information and know where in the database it's supposed to go. The part that you got to think about relative to vulnerabilities, it's the intent, or the malicious intent, that hackers have learned over the years, be it because they have that knowledge of SQL. They know, hey, if I go into the front end piece where you normally enter your data, I can write a certain, line of code, of SQL code, right? And insert it into that field. And it could give me all kinds of information depending on what code I'm writing in there, that SQL code. So it's kind of like, think about when you're playing like a video game, when you have, oh, I have a secret code that I enter, or a code to get a discount, right? Even on something you're purchasing. It's similar to that, where they're entering this code, and depending on what that code is, right, they could extract data from the system, because the system's like, oh, I'm getting a command, and the command is this, and so I will then provide this information. And so that's the part that's like, well, you don't want that, right? You're trying to secure that data. And so it's important to think about, okay, well, if there are those codes, and what do I need to do, right, to prevent, that from happening? So that gets into, what do I need to do to harden, the code that I'm writing on the back end, so that it doesn't respond to those kinds of SQL attacks, right? And there are certain ways that you go about doing it, and you can research some more when you look up, for example, what we call SQL injection, which is what this is called, where they're injecting SQL code into the front end to be able to get that data out. And there's ways to essentially kind of, inoculate, or what you might think of vaccinating your code against those kinds of attacks, right? So that when those things try to come in, they can it can be repelled, right? And the data is not vulnerable to those kinds of things. So there's it's that's one of the things. The other one too, it's when you have essentially cross-site access, where you get essentially links, right? And we are tested for this all the time in my place of business, where we get these say emails with links that look like they're legitimate requests from, say, places that you normally interact with, as like, for example, your bank. You might get an email that looks like it's from your bank and says, hey, you need to go log in because there's something going on in your account. Oh no. And so you click on the link, and then it takes you to some other place, right, that looks like your banking site, but really it's not, right? And then you start entering your credentials as you normally do. Well, that's getting stolen. You're actually literally giving it. It's like giving your keys to the carjacker and say, "Here you go." um, and then they can use that information to actually go back to the site, and do what they want, right? take all your information, be it in this case, say your app. They take all the information on the back end of your app, um, and can change your credentials so that way you're locked out going forward, and wreak all kinds of havoc um, in that kind of environment. So um, some things to think about there is, okay, well, how do I then, help to prevent that kind of attack from happening? There's certain things you can think about relative to your app, right? There's what we call, authentication, right? Where we have some kind of solution where when you log in, um, you're then you're then sent a code on your phone, right, as a secondary authentication to say, hey, somebody's trying to log in with your account, right? Um, and here's the code that you need. And because when you first established your account, you entered your cell phone, so that's why it knows it's you, and it'll only be sent to that number, right? So with that, if somebody is trying to do that and it's not you, there's other certain actions you can take: either ignore it or alert, the bank, for example, in some cases. Um, but at least from that perspective, relative, for example, to your apps, it's a way to say, hey, we got two-factor authentication. And so if somebody tries to log in, it's only through confirmation of the code that's sent to my cell phone. And once that's entered, that it would allow me to log in. Um, so that's another way to try to prevent some of those things. There's obviously, you think about hackers and they try to think about, well, how do I get around that, right? So that gets into obviously the struggle on how we maintain, say, one step ahead, in this case two step ahead with the two-step factor. But trying to stay ahead of the hackers that are trying to use means by which to be able to get into your systems to get that data, right? So um, when you think about cyber security in general, right, it's also important to kind of step back here and think about where how that's evolving, right? So you think about where you are today, right? Generating these apps and these ideas, um, and it's exciting to think about what you're trying to develop, right? Developing an app that solves some community problem, and that you're learning a lot in that process about writing code, learning how to brand your app and what colors you're choosing and the buttons and the actual community you're intending to serve. Um, and then even the idea of the marketing piece of it, right? Like, oh, I'm going to write the script and make videos, and then even the pitching to the judges. There's a lot of uh, of things that you're learning about how writing an app and being an entrepreneur um, comes together. And what I have seen with mentoring students in the past is that they learn a lots of different aspects in that process, and they also learn what they like and what they really enjoy. And that STEM is not just about coding itself. That's a key piece of it, but there's all the other pieces that go into STEM. And when you look at where you are today and writing these apps and what the future, right, of what cybersecurity is going to look like. So there are certain things to think about that we are still right now on the cusp of learning, right? So where does AI fit? Where does machine learning fit? And you think about all the awesome things that AI can do now, right? And helping and assisting us in doing things, and doing the machine learning and learning how to be a prompt engineer, for example, and the power that that technology gives us to be able to analyze data, understand trends. We can use it in our technology businesses today. We can use it in the medical field. Think about how maybe a diabetic could use it, or a doctor that's treating the diabetic could use it for certain things to understand. how to better treat them to get them a better outcome long term wise. Um, there's a ton of different things that AI can do for us, and you're on the cusp of that relative to going into fields where that's going to be, just something that's just going to be probably just uh, a regular thing that you use, much like we use computers today. If you rewind back to the 80s, right, having a computer at work wasn't something that was normal. It was far and few between, um, and nowadays, everyone's getting ones, and everyone has one, right? And even now, do you even get a computer? You probably get a tablet in some cases, and that's what you use, even at work, right? And as students, you get that now. Um, but when you think about cybersecurity and AI, right? There's going to be both how we use it to create the safeguards necessary to protect our data, to protect the transactions. But then there are the others that are going to want to use it for malicious purposes, right? And you hear some of those stories now, and obviously there's always concerns, that you hear about, what AI can do. But the challenge here, or the opportunity here, is using AI for the benefit of people, which is when you think about engineering. One of the things that I was always taught about engineering is using the material and resources for the benefit of mankind, right? Or for people, right? And so that's what I like to think about, how AI can help us in that capacity. Um, the
It is good to know the other side of that story though. So like
Yes,
you mentioned phishing and like where they will send emails or some things that look real. I think one thing to keep in mind with AI is that those things are going to get closer and closer to indistinguishable
correct,
because of AI. It's going to be able to clone certain aspects of your voice and certain mannerisms in video. So we're moving into a realm where you're going to have to question everything,
correct.
and really think about how to secure things in different innovative ways because hackers are kind of ahead of the game on
Right.
that.
And I have a pretty good example of that. I mean, you think about how things are becoming more and more real, right? You got all these fake videos that look real. I mean, and what what you have is people that are generating fake videos of people. It sounds like them, it looks like them. It has the same mannerisms as them, which you would expect. And so there's those kinds of fake videos that are coming out. But then on the flip side, what I've seen also to combat that is using AI, right? So they're using AI to create these videos. But then I can't remember which school was doing this or which company was looking at this, but they're using AI to look at these videos and be able to tell what's real and fake. And the way they're doing it is by examining the changes in the skin tone because of the blood vessels that are moving through your body. And that by
Wow, that's
looking at the
intense.
minutia, yeah, by looking at the minutia of that's how they can tell what's real and what's fake. So that gets into the idea of how AI is being used maliciously, but also how AI can be used to combat that. So that's just, I just love that example, right? Because it's like, wow, but that's the future, right? And you think about that's how it can be used both ways. So very fascinating. And that's just an example. You think about all the different ways that people are used, just how they use computers today, right? Both to protect us and also how they can be used in malicious ways, right? Um, the other part that we talk about a lot, it's quantum computing, right? So you think about quantum computing and what does that mean, right? It's it's next level type of processor that has millions more processing capability than today's supercomputers do, right? So you think about today, the traditional um, transistor based type of technology what that hasn't really changed, right? As far as how the transistor works, right? What's changed over time is that we've figured out how to make it smaller, right? And put it on a chip, right? And on a wafer, right? And so what we've been able to do is, because we can make it smaller, things can run faster, because you just think about the distance of how long it takes an electron. Now you're thinking about electrons, right? Well, they move really fast, but when it's as that's why the importance of, when you start talking about at a nano scale, right? That distance obviously starts to matter for an electron, and that's what we've done with semiconductor, is make it such smaller. But when you get to quantum, it's a different technology, even, where you have that kind of next level that runs so much faster and has so much stronger computing power, right? That it's a millions and millions times faster than our fastest supercomputers run today, which is awesome to think about how that technology will eventually evolve into something that can be used in the workplace, but or in governments, for example, or even to a level where it gets into schools. Actually, some universities are looking at it now. But you think about, for example, companies like Google, that are developed the qubit, the quantum bit, and are using it now and making it available to hospitals to use. Um, Now, if you think about that kind of computing power right now, it's not really accessible to many, but the intent of it is amazing. And again, you got to look at both sides of it, right? The ability that it brings to us that today's traditional computers just can't do. Um, and there's two sides to that: the ability to help us, but also how somebody can use it maliciously. So if you think about today's firewalls that we have in our systems, and the authentications and all the coding that we put in to help protect our data, our databases, our people's identity, people's information, something like a quantum computer could just brute force itself through those existing firewalls today. It's that kind of computing power relative to today's computers. It's like a giant versus an ant. It's like a person and an ant, right? Where the person is the quantum computer and the ant is today's computer supercomputer,
Yeah,
right?
you see like those like older shows where it's like showing hackers like testing different passwords, and it has to do it like one at a time. But when you're talking about quantum processing, that's like simultaneous. So like
Yep.
2 seconds and they've tested every possible iteration that there could
Exactly.
be, and they're in your system. So like
Exactly.
that's, yeah, it's something to think about. Like,
Yeah.
how do you protect against
Yeah.
that better?
Yeah, and then once they're in your system, they're in and out. I mean, they can just suck it out and off they go, and you wouldn't even know that they were in there, right? Next thing you know, your information is out there online somewhere for sale. You know? So that's the part that is both awesome and scary on some level, right? But just like I brought up the example about how AI is being used to create fake videos, but AI is also being used to figure out how to determine the differences. Quantum computers, you'll see that kind of thing probably in the future as well, just from if you think futuristically, what the probabilities are. But the possibilities of what that kind of technology could do for us is amazing. And plugging it into, or connecting it to AI neural nets, and being able to then use it in that capacity as well. Um, Obviously, it can be somewhat scarier for certain folks, but also if you think about the opportunities and how it could uh, help people, is something else to really explore, right? Which is what the intent is, generally speaking, for that kind of technology.
Yeah. I have one question for you, Paul. Anything come up in your, learning or your understanding in blockchain? Is that something that is, I hear that it can be more secure. I don't know if that's true, but I'm curious about like what your thoughts are on that, or how it might be used for security purposes.
Yeah, that's it. That's a good question. I think when you think about blockchain, Also gets into things like the how it's a decentralizing type of capability, right? That it affords you, and relative to blockchain, right? It really ties into all the cryptocurrencies that are out there as well, right? And you have a decentralized uh, type of currency that's not uh, controlled by any government per se, right? Or there isn't any kind of government oversight. And so there's the argument or the justification made that, hey, with blockchains and cryptocurrency, you have a more secure type of transaction that's harder to trace by anybody because it's not regulated centrally by a government, right? And so you have more autonomy, more security, the which that's part of our discussions or discussions that people have relative to trying to decentralize the internet or the internet, right? Is that by decentralizing um, the internet, you're making more secure on some level, which I think there's some truth to that. But the other part with at least the challenge, I would say, when it comes to blockchain and cryptocurrency is that when you it gets into the philosophy or the construct of how currency works today, right? Typically currency is a legal what you call today like the US dollar, right? If you go back to the early days, the dollar was backed, was on a gold standard. So you literally could take a dollar, and for that dollar, you could exchange it for gold. And eventually, we were moved off the gold standard, right? And the intent of that was to be able to essentially print more money, but that also but that dollar was still essentially backed by the U.S. government, meaning that we are good for it. The U.S. government's good for it, right? As far as its value goes, um, and that's the intrinsic value I would say that the dollar has. When you're looking at cryptocurrency, right? While it doesn't necessarily, while you have more autonomy and less traceability backed by as far as oversight from a government, type of entity, right? It also doesn't necessarily, it's not necessarily backed by anything, right? There's no intrinsic value. I can't go take a Bitcoin and say, here here's its value is this much of property, right? It's at this point, it's essentially what value we put into it or people put into it. And I think that's the argument. It's like, well, yes, but there's still value in it. We're like, well, it's
Says
not.
who?
And
Yeah.
that's the thing with all kinds of investments. Typically, it's backed by something. The dollar is backed by the U.S. government. Real estate, property, right? Stock, it's ownership in a company, right? And that's the value, right? How that value goes up and down is dependent on what we value that asset to be, right? Be it the land or the company, but in crypto, and it's unless you're tying it to something, it's just like Val said, it's whatever we decided to be. So, but going back to the idea of blockchain, right, and how it works, right? There is something to be said about the fact that it could be such that it's harder to trace and harder to hack. Um, but at the same time, that hackers are always thinking about, well, how do I figure that out? How do I crack that code, right? And if you think if somebody cracks that code somehow, some way, if they ended up getting their access to some kind of quantum computer that could get and decode that blockchain, and then next thing you know, they take it all, right? Right. Even if there's no, true intrinsic value to it, what I did have in that account is gone.
And by the time you figured out what happened, they would have found somebody to give them something for it. So,
Right. Right.
yeah.
Exactly.
Yeah.
Exactly right. So that's yeah, no, but that's a good question, and it's something that to this day, I think, it's still in its infancy as far as cryptocurrency goes, even
Well, and
though,
I always kind of wonder, like, because blockchain technology got used for that currency purpose so early, like, did it taint any other use cases of that technology that we might
right,
think about using it for? So
right.
that was totally off the cuff, and I apologize for
No,
injecting that, but
no, that's fair, and that's a very good point, Val. Because, like I said, I mean, when I think about blockchain, I automatically go to cryptocurrency. But you're right that blockchain itself, as far as its technology goes, right, and its ability to be more of a decentralized means by which to run transactions in general, could how else could it be used in different industries? And I think right now it's still in its infancy relative to that, right? Like, where else can I use that technology? um, but no, good question.
right. Well, if that was what you had, we have it's been super informational. I'm certainly going to check out that "Can You Crack the Code" book by Ella Schwartz. That sounds awesome. And I did put a link to that in the chat if people are interested in taking a look at that book. But thank you for talking with me today and for sharing your insights. And if people, are you on any social media, or if anybody wants to reach out and
Um,
talk to you?
yeah, I mean, I'm on LinkedIn. You can find me there, and always open to hearing questions. I mean, I think, we were only here for 30 minutes. I mean, we just barely scratched the surface. I
It's
mean,
no way of a deep dive, but
yeah, right, exactly. There's so much here. I mean, you think about all the different aspects of, things like security headers, error handling, logging that data, the compliance that comes into it. I mean, every country has different compliances. You think about the EU and what they have put out there for ensuring how you collect personal data, how you manage it, what you should and shouldn't do with it. And it all varies, and
that brings up a question I have for you. Like, if your product or your application is kind of global and people are able to use it in those other countries, is there a best practice for that? Like, do you comply with the most stringent law that you can find, and that's kind of your goalpost, or how do you handle that kind of thing?
yeah, that's a good question. I would say normally the best approach, if you can, is think about, well, where is this going to be sold in, right? So, for example, EU is probably one of the ones that leads the way when it comes to data privacy. Um, I would probably emulate their 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 regulatory compliance requirements. From and Relative to that, it kind of depends, right? Where is it trending? Who's driving it more so than others? And we see that right now over in the EU, where other countries and entities are following suit with what EU's doing, right? Um, and so if you were to look at, well, who is the one that's driving the trend, and most likely everybody's following them. It's typically, which you see typically, it's either EU or the US, right? So it's a matter of understanding what those compliance requirements are. Um, and even with that, some of that kind of depends on what information you're getting, how big you are, right? Those kinds of things that play into what kind of compliance I need to adhere to, right? And again, relative to where we are right now with these apps, right? I mean, we're talking about minimum viable product. But if you're thinking about, really thinking about coding and what kind of compliance you need to think about, it starts to get important, right?
Yeah,
Sure.
especially if you're taking any kind of financial data, or like having a store or something for sale in your app, like, then it gets very tricksy.
Exactly.
Yeah,
Exactly.
yeah,
Yep. Very true. Very true.
cool. All right. Well, thank you so much, Paul. And I really appreciate you sharing your knowledge with us today. And I hope you have a good rest of your day.
All right. Well, thanks, Val. Thank you for
All
having me. I
right.
appreciate
Thank
it.
you.
All right.